In the last module, we talked about arable land and where it was located at. Obviously, the use of arable land and increases in arable land will increase agricultural production, cereals, oilseeds, etc. So will yield increases or productivity increases on the land that is used in production. This module is going to talk about yield increases and the industries that those yield increases spawned. There are two readings, both of them fairly short. The first one is a brief history of corn yields. If you go to our Compass website, this would be reading 2. It'll give you a brief history of corn yields. It happens to be a Washington Post article with a interesting graph on it, so go there and look at that. The second one is a USDA article that talks a bit more about yield trends, and both of those deal with corn. So if you go there, look at those two things, and they're pretty quick reads. Here is the graph from the Washington Post article. It is corn yields. This happens to be a U.S. corn yield. The source of this is the U.S. Department of Agriculture. So this would be the national corn yield in the United States. I want to point out two things on this graph. The first is look at the last year on that, 2012. That was a drought year, and as you can see here, occasionally on corn yields we have yields that are lower. Those happen to be usually associated with droughts, and those happen again periodically. Those often raise a bit of concern if there's something longer term there. Let me update that graph, and now you'll see the same graph, except now I've added years for 2013, 14, 15, and 16 here. You see the 2012 is still below trend, but the remainder years bounce back, and we are now back on higher yields. So again, occasionally we have droughts in the Midwest. Primarily, corn and soybean yields are primarily impacted by what happens in the Midwest. So when we have a drought in Illinois and Iowa, those national yields go down. The other item that's very evident from this graph is two distinct periods. One with no trend, and that no trend period happened prior to 1940s and lasted from 1895 when we first had data until the 1940s. During that period, corn yields did not trend up or down. They roughly averaged 25 bushels per acre. You can sort of see there in the 1930s they were actually lower than that. That was a period of extended drought throughout much of the United States. Those were the Dust Bowl years. So we had no trends overall, though, in from 1895 through 1940s. Those no trends would mean that if we wanted to increase world production of crops or cereals, we would have to increase acres. The only way that you could increase production was increase acres. As you can see, since 1930, late 30s, early 40s, we have been on a steady trend upward in yields. Those trend upwards in yields are primarily due to technologies that we have introduced. And now I'm going to just give you a feel for some of the major technologies that have been introduced. This is the same overhead that we saw before. I've now taken off the trend notations and added some of the major technologies that have been introduced roughly in the time period that they have been introduced. First, we see seed genetics. We really began ramping up seed or genetics research in the 30s, 40s, and hybridization came to corn. Hybridization is where we take several lines of corn, develop those, inbreed those, and then cross them and get some hybrid vigor. All of that technology was introduced in the early 40s, late 30s in that period, and began very widespread in the 40s and 50s. We also saw the introduction of fertilizers, chemical fertilizers, nitrogen, phosphorus, and potassium. Those that began being really taking off in the 1950s. Replaced some of the depleted nutrients that were in the soil, and nitrogen also increased yields in those soils. So NP and K came on board. We also began in the 60s having chemical pesticides, herbicides to control weeds, insecticides to control insects, and there's several other fungicides to control funguses. So all of those began to be introduced in the 1960s. As we controlled those pests, the crops performed better, and we had higher yields. Final technology that I put on this graph is biotechnology. Biotechnology would be the introduction of traits into seeds. We've had the first three were herbicide resistance, BT, which protects against corn borer, and a rootworm trait, which again protects against rootworm. So we use the plant to do some of the things that herbicides or pesticides did with the plant. Those were introduced in the 1990s, somewhat controversial, and we'll talk about those again in the future. If you look at those technologies, they are also what has spawned the major input industries in the agricultural sector that provide inputs to crop farms. This overhead here shows a schematic of the relationship between input firms off to the left, crop farms, and then where output goes from the crop farms. So let's start here with crop farms. Crop farms would be what grow corn, soybeans, and wheat across the world, but in Illinois, primarily corn and soybeans. Those crop farms would be serviced by four major types of entities. Fertilizer, these are also the major inputs: fertilizer, seed and genetics, plant protection, farm equipment. And those inputs are also major sources or sectors within the agricultural sector, and we'll talk about those in the next slide. Those inputs are combined on crop farms, produce crops, and then we get the crops from the crop farm and then are sold to livestock producers who produce livestock. First processors who take corn and soybeans and make something else out of it. For corn, that could be high fructose corn syrup or something else. And then we have fuel supplies or crop farm corn going into ethanol production. Again, turning back to our input supply firms, we have fertilizer, seed and genetic, plant protection, and farm equipment supplies. Those are major firms, and let's just go through those here quickly. Fertilizer provide and manufacture fertilizers, so there are major firms that are multinational in nature and produce fertilizers. Nitrogen, and there's three major types of fertilizers: nitrogen, phosphorus, and potassium. Nitrogen is produced by using natural gas. Phosphorus and potassium are mined. Mining, again, raises issues. Some of the publicly traded firms you see listed on the right there: Agrium, CF Industries, the Mosaic Company, Potash Corporation of Saskatchewan. So you see those listed there. Those are, again, major firms. They are multinational in nature, having operations all across the world. And again, those provide fertilizers. Those firms, by the way, tend to be very specialized and tend to work only in the fertilizer industry. Seed and genetics. These, again, are multinational companies. They're involved in the production of seed. They use biotechnology, and most of their work or their competitive advantage would be brought into being or is carried in their genetics. Each one of these firms has their own genetics. How those genetics perform will largely determine how much market share each one of these firms have. Again, we have publicly traded firms in this industry. We have Dow. DuPont is the second one listed there, which owns Pioneer, Monsanto, and then Syngenta. Again, all multinational companies have operations across the world. We are going to be focusing on these in their second module. And those, by the way, second module, we'll see that those firms are in merger talks right now. Plant protection, typically manufacture chemicals. They typically manufacture chemicals for a wide variety of industry, not only agricultural industry but others as well. And the ones that they have introduced are herbicide, insecticides, and fungicides. One item to note here is that we have seen fewer new products introduced in recent years, primarily because of regulatory concerns associated with herbicides, insecticides, and fungicides. Over at the right, you can again see publicly traded companies involved with this. BASF, Dow, DuPont, FMC Corporation. Again, these tend to be companies that are involved in many industries, not only agriculture, and agriculture happens usually is just a subsidiary of one of their the subsidiary of the other of the company. Finally, farm equipment, manufacture farm equipment. These again are multinational companies. Some of the new technologies that we're seeing introduced are GPS and data collection. You again see a list of publicly traded companies over to the right. The two big ones for Midwest agriculture are Deere and CNH, followed by AGCO. I want to end this module by going back to our graph, U.S. agriculture corn yields, and again we're up through 2016, you see that there. And I've added a little line to it that we're going to call the baseline, which essentially extends the trend out. So if you can see that, and what that baseline does is says if we continue growing at the same rate, this is what we would expect going out into the future. That line, as you will see in the USDA article, is somewhat debated, and that is one of the things that we talk about often. Can we continue these trend increases into the future? As you see at the top, I labeled this Neo-Malthus versus technologists. So there are individuals in the world that, well, you would say still believe that Malthus's hypothesis is going to come true. And now I'm going to just sort of illustrate from the baseline some of the items that you might see or expect to see in other views of it. There are some that are saying that we are going to increase the rate of yield increase, and here you see that is indicated by the red line. If we increase the trend yield, then we will have more production in the world as we increase those yields. Some of the individuals that believe this are the seed companies themselves, some farmers, and there is some rationale behind that. We are introducing new technologies. We are getting much better at the large data bioinformatics. We should be able to learn more about those plants as we move forward, exactly know what the genetics causes, and maybe relate those genes to output much better than we do now, make genetics more of a science than an art. And if we can do that, we would expect to see increasing yields. On the other hand, Neo-Malthus believe that we are eventually going to run out of trend increases. That could be because the plant has reached its maximum yield potential. which most agronomists would say there is a maximum potential out there. So we reached that. Either that or climate change is going to make the environment worse, and then we're going to see stable to maybe decreasing yields. So those are sort of the views viewing forward. Now, what is interesting about that is that no one knows. I mean, this is an argument that can take place forever. We will only know whether we are able to maintain the yield increases at their current level for the next 50 years after the 50 years are over. So it's one of those questions that no one can answer definitively, but it does greatly color the policy sorts of recommendations that you do, and it would also have large implications for what companies attempt to do if they believe that they're running out of genetic progress. And again, these are issues that we will talk in future modules. Here are our review questions from this module. What are some of the major technologies that have led to growth in corn yields, and what industries did they lead to? I don't really expect you to know the individual companies that are involved in each industry, but you should know fertilizer, seed and genetics, plant protection, farm equipment are some of the major input companies. Second one, what would a neo-Malthusian expect to happen to corn yields in the future? And you should be able to answer that. Maybe provide a little bit of rationale why they would believe that. And then I will probably, when we'll talk more about this in the class, about how one can argue on both sides of that issue on corn yields. That ends our yield increases module. Again, we've seen large yield increases in the agricultural sector, particularly since the 1930s, late 1930s and early 1940s.